Good evening. This is Ryane Austin, and this is my ADTA 5240 final project submission. Um, the project started with an executive summary um, explaining why we need to deploy a big technology solution. And of course, our recommendation for our company is to utilize the Apache Hadoop ecosystem. But in addition, I also wanted to recommend to the executives that we purchase or utilize OpenRefine. Just from experience, knowing how difficult it is to clean data, I think this is such a key component to deploying a big technology solution. So I do recommend to our executives that we do that as well. Um, For the next steps for the executive team, I recommend that we identify who our data analytics team is, ensure that they are skilled in the SQL language. They'll be able to adapt quickly to high SQL if they're not familiar with it, which they should be. And then one of the most critical pieces that I think often gets overlooked is ensuring that we have a business partner to support our data analytics team so that they can understand, can help the data analysts know what they're seeing in the data, why they may be seeing certain patterns, and even from a cleaning perspective to understand where you may be able to replace values, where you may be able just to downline values, that type of thing. The next piece of the project was regarding data processing. And in this particular exercise, we took an Excel document and really just I worked within the Excel document versus pulling it into OpenRefine or something like that. It's a fairly easy task to do simple remediation in Excel. In this particular case, I clicked on a column and I wanted to remove a columns. Or I wanted to apologize, remove commas within a column. So for this, I did find and did the comma and then replace with, and I left that blank. I did ask it to search within that column. And so you can see from the result, which is a little bit small, but you can see from the result, let's see, that it was 3,120 replacements. Let me zoom back out just a little bit for this data set. So while I do love OpenRefine and was very excited to be introduced to that application, in this case, it was just easier to work this within the Excel document. The next screenshots actually show the OpenRefine, which, like I said, I really do appreciate and enjoy because it's an easy way to quickly clean your data. And in this example, we fixed the postal code. So the postal code, as you can see in the top, in the top screenshot, my apologies, in the top screenshot, there are some zip codes that are only 4 digits. So obviously those are incorrect zip codes and we want to go ahead and remediate those. So what I did, and then you'll see in further screens, actually you'll see here, is I created a column based on the column postal code. And then I used the expression if value.length greater than 4, value 99999. And basically what that did is it took all of those zip codes that were too short and replaced it with the properly lengthed zip code. Then I reran the facet for postal code and from the column postal code new. And you can see here at the bottom that we now have several records with the postal code of 99999. the Apache Hadoop ecosystem with Hive. So this section was really about using the commands and within Apache Hadoop. So for this one, um, the first step that I took was to actually run the command to list all of the folders that were within user. So you can see here that I have the R Austin 1231, which is the primary one that I'll be working with in this section. The next thing that I did go ahead and run a list for that folder just to see what was in there and really just getting practice running the commands. And then I actually ran it for the folder data to see what was in there. Actually, first I created a folder. So let me back up. First, I created a folder so that I could take the sales records data from the compute engine and bring it over here into Hadoop. Have a folder for it to be placed into. So I used this command line here with make dir, and I created a folder called sales records. Then you can see here, I listed it just to make sure sales records was really there. The next thing that I did after I made the sales records folder is I came in here and I ran this command gsutil, and I basically took the data set that was in the GCP and I brought it over here to Hadoop, and that information is now here. But then I needed to run another command, hdfs, with the /put, so that I could put that information into the sales records folder that was created. So I put it there, and that way the information was available so that we could start running commands from it. So next, I needed to get into Hive to actually start running the command. So again, use the beeline command so that I could get into Hive first. I used show tables multiple times just to make sure that things are there and they're looking the way that they're supposed to look. But the first thing I did was create the external table, if not exist, sales records one. Use this command lines, and then it's very tiny, but you can see here, make it a little bit bigger. You can see here, it's still pretty tiny, that it created the table. And then the next thing that I wanted to do is I really wanted to see what were the column headers so that I could write a more detailed schema. So I took all of these, well, first I ran the command line select so that I could see the first row, and then it populated here with all the column headers. Next was some difficulty in reaching out several times with some questions. I did finally get the new schema written. So I created a table, and I actually used the underscore for some of the column headers because they had spaces in them. And first I tried pushing the two words together. I tried using a hyphen. None of those all resulted in errors, multiple errors. So once I used the underscore, then it properly worked. And I used all the column headers that you saw on the previous screen, and then created sales records for. Then I wanted to run the top 5 states. So I did that by choosing customer ID and running account off the customer ID. For the sales per zip code, I ran a sum of sales off the postal code. And you can see here the result of those messages. So here's where you can see I used each column header for and put the underscore there so that they would all show up properly. I do understand that now that it will not parse data. You can't just pick and choose what you would like to use from that first row. You do have to use all of them when you create your schema so that you can start writing, or when you build your table so you can start writing your schema. Then we have here the example where I ran it by the count of the customer ID, with California coming up with the most customers at 2001. These are your top 5 states: California, New York, Texas, Pennsylvania, and Washington. Then I went ahead and ran the sum of sales. And when I did that, postal code 10024 comes up first with 72,508. And the next screen shows the same thing. I just copied it in here twice. After many difficulties, I wanted to make sure it got in here. So in this next section, we're wanting to demonstrate how more quickly Spark can run versus just Apache Hadoop. So when I ran the commands for the state and I ran the commands for the postal code, they took 28.42 seconds and 17.089 seconds respectively. Then when I opened up Spark and I typed in Spark-SQL into Apache Hadoop, got it pulled up, the same commands took 13.348 seconds and 10.889 seconds. So you can see it's significantly faster to run it in Spark than it is to run it in Apache Hadoop. These are the screenshots that show the differences in the times. And the reason for that, in the Apache system, both Hive and Spark SQL use Metastore. Um, all Hive implementations need a Metastore. Hive must work though with MapReduce and HDFS to run the query. But the benefit of Spark SQL is it can work directly with the Metastore, saving significant time in communication. So that's why in the previous examples you saw such a difference in the timing here. 28 versus 13.348 and 17.089 versus 10.889. And this is actually the end of the presentation. Just come back here. So to sum it up, there are many benefits and many reasons why we need to deploy a big data technology solution. In business today, in my business today, there's a critical need to understand the data that we have available. And when a company is unable to access or tap into the vast amounts of knowledge that are contained within their 4 electronic walls, if you will, but within their data stores, if we can't understand what's in there, we're losing a great competitive advantage. Um, we are facing that concern in the company that I work for. We have wonderful, vast amounts of information, but because it is stored improperly, it cannot be cleaned with the technology that we have, or we don't have the expertise to know how to do it, don't have either the right folks to tackle these types of questions, or we haven't taken the time to train them properly. But we miss out on significant competitive advantage by doing that. With that being said, we are beginning to recognize this. and completely ramp up our data analytics group. One of the things that I'm going to recommend um, to our data analytics team are some of these cleaning applications that are available, like OpenRefine. I believe that if they had those types of applications, that we could probably be a lot further along in our data analysis than we are today. Um, it does feel like with such a large company that we are a little bit at a disadvantage by not understanding what we have available. With that, um, thank you for your time, and I do appreciate it. And have a wonderful evening. Thank you.